So for section 3, we're going to still be working with inverse functions, but now we're going to look at rational inverse functions. So some notes here. Recall when we have fractions or rationals, the domain is all the values, so from negative infinity to infinity, minus the values that make our denominator 0, the values that make our fraction undefined. All right. Also, what's important, and I'm recalling from above, so the domain of f inverse, so what I have here is, so the domain of f inverse, how to find it, it says solve for when the denominator is 0 and exclude that value from your domain. So it's just as if we find the domain of f. And then for the range of f inverse, so I've always found it easier to find your domains rather than your ranges. So, but keep in mind that the range of f inverse is the same as the domain of, I don't know, I have h here, sorry, but it's the same as the domain of f, right? Or whatever function you're given, f, g, whatever. So we're going to solve for, it would be f, to stay consistent with this, it'd be the same for f denominator, solve for it when it's 0 and exclude that value, right? So let's do an example to show you what I mean. So our directions say the functions defined below are 1 to 1. Find the inverse and state the inverse's domain and range in the interval notation. So we got to find 3 things. We have to find the inverse, and then we have to state the interval's domain and the interval's range. Right? So first things first, let's find h inverse. Right? So how do we do that? So first of all, we have h of x, so I'm going to change that into y. Okay, now we're going to interchange y's and x's. So keep in mind here, the examples that we've done before, we only had one x and one y, right? But it's still, so what is the difference here? Now I have 2 x's, but guess what? We're still going to interchange them. So wherever I see a y, I'm going to plug in an x. And then wherever I see an x, I'm going to plug in a y. Okay, every single x that I see. Right? So now let's solve. I'm going to multiply both sides by 9y minus 8. So I have 8 and then 9y minus 8 is equal to 4y. Right? So this one's a little trickier because as you can see, we have y's in 2 places. Okay, but have no fear. It's just a couple more steps. So let's still distribute x to both sides, or to both terms. So I have 9xy minus 8x. This is equal to 4y. Oops, sorry. I don't know what I'm doing. This is 4y. Right. I'm going to bring my work back to the top. Okay. So now our goal, so what is our goal? Our goal is to solve for y, right? So what am I going to do? I'm going to subtract 4y from both sides, and I'm going to add 8x to both sides. And so then I'll get 9xy minus 4y is equal to positive 8x, right? So now that I have all the terms with y on one side, and the y is linear, I can just take out the y. And so I'm left with 9x minus 4 is equal to 8x. So now we divide both sides by 9x minus 4, and so I get y is equal to 8x, 9x minus 4. Now don't forget, what are we looking for? We're looking for h inverse of x. We're not looking for y, we're looking for h inverse of x. So this just becomes h inverse of x equals 8x. Okay? If you skip this step, you will lose points because this is not what you're looking for. This is what you're looking for. All right? So we have found h inverse of x. Now the next things that we want to do is we want to find the domain and we want to find the range of these. Right? So domain, so domain is just how we would as if we would solve for h of x. So we're going to get 9x minus 4, and we're going to set it equal to 0. Going to insert some space so you don't have to look so low. Right? When I solve for the domain, I get 9x equals to 4, and then we get x is equal to 4/9. Okay? So the domain, and so I'll do it two ways. The first way I'll do set notation. So remember, it's the set of all x's, okay, such that x does not equal 4/9. Okay, this is set notation. So now what is interval notation? So this is set notation. So interval notation is going to be negative infinity, and then keep going, and then we hit this wall at 4/9. Okay, union, and then 4/9 again, right? Because it's just 4/9, but we could be so close to 4/9. It could be I don't know, whatever 4.19 is in a regular fraction that's not complex, right? It's just not 4/9, all the way to infinity, right? And this is our interval notation. So lastly, we want to find the range of f inverse, but I don't know about you, but I don't like finding range. Okay, so how can I do this more nicely? So look at this note. So we know that the range of f inverse is the same as the domain of our function. Okay, so what am I going to do? I'm going to get this function. So I have h of x equals 4x over 9x minus 8. I'm going to take this denominator and I'm going to set it equal to 0. Okay, so range, we have, what was it again? 9x minus 8. Okay, so when I do that, I get 9x is equal to 8, and then x is equal to 8 over 9. Right? So again, set notation. Okay, set notation is a set of all x's such that x does not equal 8 over 9. Okay, the reason why this is equals is we're finding when it becomes undefined, right? But when you actually tell me technically this is the range, or this is the domain of h, right, or whatever, you have to exclude the value. All right. So now let's find interval notation. Okay, interval notation is the same thing. So it's just all real numbers. So negative infinity to infinity. However, we do have a bump in the road, and that's at 8/9. So we have to go negative infinity to 8/9. We got to stop there. Okay, and then we go back. Okay, so to be more clear, domain is negative infinity to 4/9 to infinity, and then our range is the same as the domain of f, which is negative infinity to 8/9 and 8/9 to infinity. Right, so this is the domain and range of our function h inverse of x equal to 8x minus, or over 9x minus 4. Right, so then the last topic we're going to talk about today will be quadratic, cubic, and radical functions. So I'll see you in the next video.